Pile Dynamic Test Operating Guide. Align the red dot with
Insert
the red
channel
dot. 1 or channel 2. Long press for 3 seconds to turn on. Click here to test. First, let's click on this parameter. This is to set the project name. The second is to set the pile number. We can click to create a new project name. Then enter a random project name and click OK. Then create a new pile number. Just create a new pile number. Then click the up arrow. You can enter special characters. Then enter our estimated pile length and wave velocity. The estimated pile length is 5 meters. The estimated wave speed is, for example, 3800. That's it. This is the basic information. Then here is the information of the pile. According to the specific pile information, you can enter them one by one. Then here is the advanced settings, which sets the sampling interval. After entering the pile length and estimated wave velocity, the sampling interval is automatically calculated. This is the sampling length. Sampling length is the length of waveform we collect. Generally, 1024 is enough. This is the number of sampling channels. It is related to each measuring point, at least. Guaranteed 3 sample channels. Acquire 3 signals. If you have 1 measuring point, choose 3. 6 for 2 measuring points. And this is the number of channels per screen. Mode. It means how many waveforms are displayed on one screen. This is the gain and trigger level. They are a pair of corresponding parameters. If you choose gain as 1 to 50, then the trigger level should be low. Your gain choice is 20, 50. The trigger level is medium. If the gain is 50 or 100, the trigger level is selected high. The larger and longer the pile, the higher gain you choose. Just choose this low. The number of hammers. 1 hammer produces 1 signal. And this one is the sampling channel, the channel number of the sensor we insert. You can choose the channel number. We inserted into channel 1. This is continuous acquisition mode. It's continuous acquisition mode. It means 1 hammer produces 1 signal per hammer. If you choose single, it means that after hitting 1 hammer, click sampling on the instrument, and then hit the second hammer, then it will be saved. We usually choose continuous mode. Receiving mode. There are automatic, manual, and all options. Generally, just choose all of them. If you choose manual, if you hit too hard, the instrument will tell you that you hit too hard if you want to keep this signal. If it's automatic, the instrument will tell you too hard to hit and ask you to knock again. It will directly give this signal. It won't be saved. It doesn't save by default, or as long as we tap, can trigger the reception of our signal. It will save this waveform and prompts you to tap lightly or heavily, or too light, and ask you to hit harder. Then the horizontal axis can have 2 parameters, or length. It depends on your preference. After all the selections are done, click OK. This will enter the sampling interface. We can click sampling, and then tap. After tapping is completed, click stop. That's it. If we want to test the next pile, we can click on this to create a new pile, and save this pile, and then create a new one, such as 345. 3451, OK. Then click sampling. Or, you can knock down a stack. Stop. Then you can continue. And directly save this name. Enter 346 and save it. And it will automatically generate 347. Then click sampling. Stop, and we're done. If you don't test the next pile, after you finish testing, just click OK. Next, we will enter the analysis. This is the exponential magnification, which we use more often. If the signal at the bottom of the pile is not particularly obvious, you can scale it up exponentially. This is the magnification factor. to amplify a certain multiple. Generally speaking, if the signal at the pile bottom is not obvious, we can use the exponential amplification. If you use exponential amplification, if you adjust the magnification it will distort the waveform. This is the starting point of magnification. For example, if it's 15 meters, and the first 10 meters of fine, I start to zoom in from the 10th meter. This is the wavelet factor. The wavelet factor is from the algorithm to smooth the waveform algorithmically. Generally, we should not exceed 1, below 1, for example, like 0.2, because if you make the wavelet smoothing too high, it will distort the waveform and filter out the useful signal. This is waveform rotation based on this starting point and rotated up or down. This is the smoothing points. This is to smooth the waveform from the image. To smooth the waveform. This should not be too large. Generally, it should be less than 20. It's just in the single digits, around 5. And then there's filtering. The filter types include low pass, high pass, band pass, and no filtering. Generally, we do low pass filtering more. Band pass. If you find that after knocking, there are many spikes, and the waveform has many spikes, we can do a low pass filter. The high cutoff frequency of low pass filter, generally not exceeding 1200. No less than 1200. It's all above 1200. The lowest is generally 1200. Then we can choose to judge the bottom of the pile. For example, if I click here, I think this is the reflection of the pile bottom. If I think this is the bottom reflection, we can click to mark the pile bottom. If there are defects in the middle process, and I think this is a defect, we click on this defect. This is if you mark. We generally mark them as defects and expansion defects. Generally, we don't mark segregation, mud inclusion, and cracks. Generally, we only mark defects and neck expanding defects, then mark the degree of the defect. Whether it's slight, ordinary, or severe, that's all. After marking, and you think the marking is wrong, you can click Clear Defects. You can clear all the defect marks. We have completed the analysis. Of course, these can also be analyzed on a computer. We select the file menu and save it. When exporting, we export. It is guided in units of project name. We select this project and then click Export. Insert USB stick and click OK.